Okay, so then let's get started with the talk of today. GUI meets web with Chromium Embedded. Chromium Embedded, or Ceph or CefSharp, I'll explain the names in a bit, is a tool or product, a project that allows us to embed the technology of the Google Chrome web browser into GUI applications. And I would say over the last 2 years or so, every now and then, companies that we have already been working with or have not yet been working with us reach out to us and said, hey, do you have experience with using CefSharp? Because we're looking for a modern web browser control to integrate web applications into OpenEdge application. And that's really what I'm going to show you, what it is and how it can be embedded into OpenEdge and yeah, some of the possibilities that brings. Yeah, I'm working for Consulting Work. We're an independent IT consulting organization focusing on consulting services for companies using OpenEdge. We have specialized ourselves on OpenEdge and other technology like the .NET framework or web technology like Angular, object orientation, software architecture, and application integration. We have offices in various countries in Europe. Our main office in Cologne in Germany. We have a subsidiary in the UK. That's where James and another colleague are working. With an office in Romania. We have a couple of colleagues working from the Netherlands. And from there, we're supporting customers all over Europe, North America, Australia, and South Africa. What we do provide to support our customers are either developer tools, developer frameworks like the Smart Component Library, which I'll briefly introduce in a second, and consulting services. Yeah, I'm Mike Fechner, supporting our customers here as an architect during application modernization projects. But I'm also working as a product manager of the Smart Component Library and the WinKit, our two tools. I'm also working as a developer still every now and then when I find the time. So I still have hands on my keyboard quite frequently. I'm using Progress OpenEdge, or what is now called OpenEdge, for over 31 years now. So I started in version 5. So I've experienced a couple of changes in OpenEdge 2, and that's generally something that helps me understand where our customers might be still, and yeah, give them some advice on where they might want to go to with the development. So with the Smart Component Library framework, we are providing developers with a framework, with a tool which supports the ability to help to protect the investment made in the past 20 or 30 years into the OpenEdge application by allowing the OpenEdge application to be opened up for future passes, for new user interfaces, new programming techniques, new integration with other applications, etc., etc. The applications that we then modernize with the Smart Component Library generally can be deployed either in the cloud or still on-premise, either with or without the app server. So we have an architecture that allows us to use the app server. We still support fat client deployments if that has been used in the past. We're following the guidelines or the principles of the OpenEdge reference architecture and the common component specification, provide a lot of tooling, APIs, base classes around that to make development of new applications easy. And we especially have tooling that supports developers with re-architecting existing applications. In the framework, we do provide a number of user interfaces. We have a Windows desktop UI. That's really what we started with way over 12 years, 50 years ago with a Smart Component Library. That's based on OpenEdge GUI for .NET using the infragistics controls that Progress has bundled into OpenEdge. We provide a framework for Angular-based web applications, where we also use the GUI components from Progress's Telerik branch. Mobile applications based on native script with a lot of similarity in the developing model with the Angular web application. That's quite nice. We provide open standard-based interfaces such as RESTful, which allows customers to build their own front ends if they prefer. And we have partners that have built their own alternative front ends on top of our back end. So there's quite a variety of user interfaces that can be used with the Smart Component Library. So the agenda of the talk this afternoon is well, CefSharp. I'm going to start with some thoughts generally on modernization applications and why something like CefSharp might play a role there. Then I'm going to introduce CefSharp and also provide a comparison to kind of like a new competitor to CefSharp that has been released just a couple of weeks ago, the Microsoft WebView 2 SDK. And then I start introducing how to use the web browser control in the application and what that leads to in terms of application architecture and certain challenges or possibilities arising from that integration, like authentication, navigation within the web application. SPA there is the acronym for Single Page Web Application, which is the architecture of the modern web development frameworks, and how the desktop application can interact with the web application. Okay, so when we start talking to customers about application modernization, generally there are certain reasons to do a modernization. They might be coming from functional requirements, so customers might need to add a new module to an application, or the requirements for an existing module have changed so much that that could actually be a start an initiative of saying, hey, if we need to redo our order entry module completely, why not do it in a modern architecture? That might be driven by business or legal requirements. So maybe there are so many legal changes that have an impact on the implementation of an application that based on that new architecture might be introduced as well. More often, the demand to us is that we support our customers in implementing the so-called non-functional requirements. So not what the application is doing, more the how is the application doing what it's supposed to do, how is the application solving the user requirements. And that could be like introducing new user interfaces or improving the user experience. So going from the classic progress gray screen into a more modern desktop UI, or even going from TTY to a modern desktop. It could be going from whatever desktop UI towards web or to mobile. Could be that for whatever reasons, there is already awareness that a new architecture is actually the driver, the need for new architecture is a driver for modernization. Sometimes the need to deploy in clouds is a driver for modernization. If you deploy a fat client application in a public cloud or in a private cloud, very often you have to use either Microsoft Terminal Service or Citrix, and that are products which add their own extra license costs, and that might be a problem for the business model. So when we look at then strategies to fulfill the new requirements, there are really two different approaches. One is the customer might already know, well, we need to modernize the whole application, and that is the project. So going from either TTY or the classic ABL GUI to the modern desktop, web, or mobile. That may, if it's not done properly, lead to the fact that we have to decide quite early in the process on the final UI technology. So if such a modernization project goes over a couple of years, and at the beginning we would have to make a decision on, oh, what would be the web technology to use for the front end, that can be a problem because web technology changed so fast, and the decision for web technology that we do today will certainly be not the same decision we would be making at the end of such a project. And worst case, the web UI technology might not even be supported anymore. I'm personally convinced by the fact that the web UI is not always the best solution for every application. It is probably a good solution for many applications, but not the best for every application. There may be applications where desktop UI might still provide better user experience to the users, might be easier for the development team if you have a small development team. Splitting your resources in backend ABL programmers and front-end JavaScript programmers might not be feasible, etc. And that very often leads to considerations where instead of going from the status quo straight into the final solution, we go via an intermediate. And the intermediate might be that within the existing GUI application, we embed either a new desktop UI or a web UI that then is using business logic that could be used for any of the front ends that may come. And by that strategy, we can really modernize screen after screen after screen, use whatever is a good intermediate UI technology today, prepare the business logic, move it to the app server so that that could be used by whatever UI technology is the state of the art when we're getting towards the end of the modernization project. And that's a strategy that works very well in many projects. And for other customers, it's a good decision to just start with kind of like a pilot and add mobile clients for small parts of the application or RESTful interfaces to enable the application for data exchange with other application. And these things, they generally reduce the risk. The company can just try out new technology, get experience in what it means for developers, for deployment, etc. Gather this experience without making decisions with impact for a much longer project scope. So, and in that realm, the usage of a modern web browser may become relevant, and that's where CefSharp is the kind of like the leading web browser component for embedding it into your application. So what does it stand for? CEF stands for Chromium Embedded Framework. So Chromium is the open source version of the Google Chrome web browser. When Microsoft started using Edge as using Google Chrome technology to release a new version of the Edge browser a couple of months ago, they also started with the open source code base from Google. That's available on GitHub, and everybody can look at it and download it and do what they want with it. The purpose of this is it's embedded. So we get a browser component that we can embed into our application, and that just does not mean that we have the browser window being part of our application windows. It's really embedded in the sense that we need to bring the browser to the user ourselves. It's not like an OS component that the user needs to install up front, we bring it. And yeah, it's a framework, so it's not a browser application by itself. It allows us to develop a browser application in the way that we need it. So not an independent web browser. So and then we have CefSharp, and CefSharp is basically taking the Cef Chromium Embedded Framework and integrating that into the .NET framework. C# is the language of the .NET framework. So that's how the name CefSharp is assembled. So it's released under the BSD license. It's open source. BSD license allows us to embed the open source application into commercial application without having to open source the commercial application. Yeah, CefSharp is just the most popular open source project in that area here, based on Google Chromium, the foundation of Chrome, and it provides a web browser that can be embedded in WinForms or WPF applications that are two different UI technologies used in the .NET framework. And especially the WinForms one is the one that we can use in an OpenEdge GUI application through the GUI for .NET technology. So we can actually embed this into OpenEdge GUI applications. Certainly all the OpenEdge 11 releases, and those would be the release that I would care about most because they are still under support. But it might even be possible to embed that into a 10.2b application, but that's something which I actually haven't tried yet, but 10.2b would also be supporting GUI for .NET. So on Google Chrome is a very good foundation. When we look at the browser market share, then we see the blue line, that is Google Chrome, that has been made, well, it's available now since 12 years, since 2009, and constantly grew in market share. Now in Germany, this January it had a market share of 47%. And we see all the other browsers, or most of the other browsers, something like Internet Explorer, has completely disappeared, and others are very, very low. Well, then there's Firefox that has a certain relevance, so different in geographies. We see Firefox has also been from being the market leader with 60% 12 years ago. Now it's also just more like one of the other small ones. So I think if any political party would win the elections with 47% and the next one at 20%, it would be clearly stated as the absolute winner. And I'm pretty sure the statistics would be the same in the United Kingdom. So CefSharp is the de facto standard to embed web browsers into applications, and many well-known applications are using that. Applications from Adobe, Amazon, Spotify. If you see articles about the artist in Spotify that's using CefSharp or Cef, and virus scanners, many games. So it is not just, it's not an exotic solution to use, it is the state of the art. And what does it mean? Well, when I was traveling to Australia, I learned the concept of bring your own bottle to the restaurant. This means bring your own browser to the application. So unlike the Internet Explorer or Edge, which are typically installed as part of the operating system, if you want to use CefSharp as part of your application, you have to bring the browser to the application. And that has a couple of advantages. So first, it means, well, we have to carry a bit of binaries in our backpack. So there are a number of DLL files and executables and all sorts of other files. We need to bring them to the user. That also means the user doesn't have to install anything up front. We're not so much dependent on the user. And this is copy and paste deployment. There's no need to add any registry keys or whatever. We just zip this folder with the version of the Ceph browser that we want to have and copy as a part of our application. So there's no dependency to anything, and there's no dependency to Google Chrome. So we know we can use Google Chrome browser technology whether or not the user has actually installed Chrome on his PC. The only dependencies that we have is we need an up-to-date Visual C++ runtime and the .NET framework, but at least on every relatively modern Windows PC, that is guaranteed to be available. So, and what are the benefits? Well, we were able to integrate very closely with that in the application, and I'll show that later. We use a very modern web browser, but we're also able to upgrade the browser at our own control, and that is sometimes very, very important. From our own development of our Angular web application, and know that throughout the last years there suddenly have been surprises. Suddenly Google Chrome was enforcing a so-called secure cookie requirement, and until we had changed the configuration of our test path OEs, our Angular web application didn't allow to log in anymore, just overnight. And it started with those users that have updated Chrome first. And same with suddenly some SSL certificates are no longer valid because the root certificates are no longer trusted by the browser vendor. Probably all for very good reasons, but if that happens overnight with outside of your control, that is just a risk. And from testing standpoint, we know exactly the version of the browser that we're shipping to our users, so we can test that, exactly that version. And usually, even if then our testing phase and releasing that at our own pace means we're working with a browser that might be 3 or 4 months old, that's still pretty up to date. Another thing is we have full control on the browser's cache. If we provide modern web applications like Angular-based web applications or also the other frameworks, they rely on large libraries of JavaScript code or images or cascading style sheets. And when those are updated to new versions, then sometimes the browser's cache can be actually not really helpful. And I've heard conversations between web developer and the tester that start like, oh, you're saying it doesn't work as it should, so have you emptied your browser's cache? And the tester says, of course. And then the developer says, have you really emptied the browser cache completely? The tester says, I believe so. And then the developer might say, hey, you need to go into the Google Chrome debugger tools, right-click on the refresh button, and then you see a context menu there which actually says, well, completely delete cache and completely refresh the application and that stuff. And that's something that I think would be insane if we have to enforce that from a normal user. So we can completely control that if we bring the own browser and know where this cache folder is programmatically. We can also use CefSharp in a version that absolutely has no cache on disk at all. CefSharp is pretty up to date. So these are screenshots that I took in beginning of February when I gave this presentation for the first time for the German Progress user group. And at that time, so on the 10th of February, my Google Chrome had a version, and it said it was up to date, called 88.0. whatsoever. And on the right-hand side, you see from the CefSharp GitHub pages, the versions that are available there. So the stable version was one version of Chrome behind. So that means a version in a couple of weeks. But there were pre-releases also based on the version 88 code base and nightly builds that are also based on that. So we can decide to be very, very up to date with Google Chrome so that we're not missing any features that we need. So how do we get access to that? Well, you either, as a developer, clone the GitHub project from the CefSharp webpage, GitHub page, or you get access to the binaries from a so-called NUG repository. That's something that .NET developers know. It's just a package repository, public package repository, and there you get access to the DLL files. We have decided to use the source code from the GitHub repository because we felt it was quite helpful for understanding how the browser works to be able to debug it, and debugging then requires source code. That also contains a sample application. And since we realized very early that we need to build our own .NET assembly for integration with OpenEdge, we needed to use the Visual Studio anyway. And the most important feature or requirement that we had is the .NET-based CefSharp web browser may raise events from background threads. Web browsers may be loading web pages asynchronously, and web pages may be raising events asynchronously. And in the ABL, since the ABL is single-threaded, we can only deal with events from the foreground thread. So we needed to, specifically for usage in OpenEdge, deal with event synchronization or thread synchronization. And that's something that is not a lot of work, but you need to do it, and therefore you need the Visual Studio to do that. So when we downloaded the solution, as a black screenshot on the right, you see the Solution Explorer from Visual Studio. I only have access to a German version of Visual Studio, so you have to live with these screenshots in German here. And there it has a couple of projects, and the full source code is there. And you see by the images, those with the green box that are C# projects, those with the purple box that are C++ projects. So it's a mix of those. And the C++ port actually means we need to know whether we're targeting CefSharp for 32-bit or 64-bit Progress runtimes. So whether we're executing it in Provin32.exe or in Provin.exe, that are separate set of DLLs that we need to build. So .NET Framework usually produces platform-independent binaries, and platform here means 32 or 64-bit, but C++ is generally byte size dependent or word size dependent, and that's why we need to build it separately. So I mentioned the requirement to do the thread synchronization of the events, and what this means is we just have, well, it's a bit more than one class, but for simplicity, one class here that subscribes to the actual events of the web browser, like the address has changed, or the title of the web page has changed, or I start loading the web page, or there's load error. So all these types of events that may happen when using the web browser. And on the bottom right, we see that we need to subscribe these events, and in the event handler in C#, use then this construct with if invoke required, then this dot begin invoke, and that just means this invoke requires tells us whether we need to use begin invoke to synchronize the event handling from a background thread into a foreground thread. So it's not a lot of code, and we do that with a number of other assemblies as well in the .NET world. So that had to be done here too. So some of the other nice features there, Google Chrome provides a very nice and powerful debugger, and probably Google Chrome is a browser of choice for most web developers because of these debugger tools. That provides a log console where the front-end code might provide log messages to the developer. We all know that messages is a very powerful method of debugging. It provides tracing of HTTP requests, so we can see which HTTP requests the browser does and the responses of those. But we can also do step-by-step debugging of the JavaScript code. And that's possible with CefSharp-based applications too, by actually using the debugger features of the Chrome browser and then sort of a remote debugging. CefSharp also has a headless browsing support, so we can use the browser without showing its UI. And still interact with web pages and inspect the contents of web pages from the application. And that could actually be a foundation for using a web browser to kind of screen scrape contents of the web page and maybe import it into an application or remote control application. And unit test frameworks for web pages are using Ceph or CefSharp typically as a foundation to do exactly that as well. We can use freely set the user agent. So actually, our application could identify either as Google Chrome or as our own string, and that could be used either for browser-based statistics, or the server could actually distinguish the output he sends to the browser based on whether it's CefSharp embedded to our ERP system or whether it's just Google Chrome. What is not part of the controller are controls as a back button or the address bar. So that's something that you typically implement as the application if you need it. So let's briefly talk about the new kit on the block, WebView 2, and it's the previous version, WebView. So WebView was for many, many years the standard solution to embed web pages into applications. It was available as an ActiveX control or .NET control, and is based on Microsoft's Internet Explorer. The version of Internet Explorer used did depend on the version of Internet Explorer available on your PC. And that was commonly used in OpenEdge applications, either for embedding web application, or many people have used it also as a very easy way of viewing PDF files. And then actually the Adobe Acrobat plugin of the Internet Explorer was then visualizing PDF files or Excel files or whatsoever. Problem there was, Internet Explorer has never been the best browser. And I'm pretty Microsoft friendly, so I'm not just saying that to bash Microsoft there. But with modern JavaScript frameworks such as Angular and also React or the others, these applications are known just not to work well in Internet Explorer. And Internet Explorer has been retired by Microsoft, replaced with Edge, but still the web view that is still available today is based on Internet Explorer technology. So Microsoft released in the second half of last year WebView 2, and WebView 2 was released then along also the release of Microsoft Edge based on Google Chromium, and it's pretty similar in many features than CefSharp. At first view, it seems a bit easier than CefSharp, but it's lacking a couple of features. It doesn't provide the debugger features. It provides the browser console. So if you have messages or console log statements in your JavaScript code, those will be are available in the WebView 2. But not a full website debugger. It's not as widely spread as CefSharp yet. The .NET version has only been released this January, so 2 months ago. The C++ component, which we cannot use in OpenEdge, has been released in October last year. So it's certainly still needs to really prove that it's a good alternative to CefSharp. So we at least do not plan to switch immediately from CefSharp to WebView 2. We're still feeling quite comfortable with CefSharp. And one of that reason is, well, WebView 2 is again an OS component. It's not the embedded browser engine. So we are afraid that by using WebView 2 instead of CefSharp, we're again dependent on, or we again might be surprised overnight that a user installs a new version of the browser and suddenly we have to deal with new restrictions in the browser. And that seems to be quite, well, risky from our point of view. So therefore, we're probably going to stick with CefSharp. So how do we use CefSharp in the application? Well, CefSharp has a lot of configuration settings. You see some of them on the right-hand side. And that's they are made available or accessible through a C# class called CefSettings or CefSettingsBase. And that allows us to set all the various properties that a user could also be setting in the Google Chrome preferences, or that would be just enforced by the browser setup. So we can control through the locale the languages of the browser. We can provide the directories for the caching. We can provide log file settings, etc. The remote debugging ports, so that's the ports that we would be using for debugging. So all that is there, and we can set it to code and then use it either with hard-coded values or provide that through, well, the application configuration files or whatsoever from the ABL application. So then to use it, well, this is now an OpenEdge ABL based .NET form, because I need to embed it into a .NET form, but that runs in the Progress runtime. Well, we've called this class the browser form. We can provide an URL to the constructor of that form, and that form creates an instance of the Chromium web browser class, and that's actually the full implementation of the browser. And then after setting a couple of other properties about sizing and where it should be placed, we just instruct it to load the web page on the given URL. And well, I can show that now within an application. So that's a Progress GUI application. Could even show classic ABL screens here running in the same runtime with typical messages. But at the same time, I could be, for instance, starting a browser showing a web page, and this is now on DHL tracking. I have pre-filled here a parcel number from DHL. In the real world, that would probably be coming from an order table or so, where you're tracing orders and want to see where the shipping is. And when I open that, we're just seeing the regular DHL web page, and I see the fact that, well, this parcel has actually been delivered already last month. So if we look at the code for this, it's a very simple ABL procedure. You see here we have the parcel number. Then we have here a simple API that shows the dialog to ask for the parcel number. And of course, in between here, we could be looking up an existing order in the database and fill in the tracking number from there. And then we're getting a reference to a service that manages the CefSharp browser for us here. And that's the German tracking address for DHL. And we know from looking at how this URL looks, look how the address to the web page would be constructed to provide an existing parcel number. And these URLs, well, either you just look at the URLs of public websites and you recognize this yourself, but companies such as DHL, which are really keen on providing business to integrate with their website, they actually provide documentation on how to build up these URLs. And if we look into the implementation here of the service, then we see that this is opening the browser form and then navigating to the URL. And in this browser form, we are pretty much seeing the source code that we had on the slide as well. We create the instance of the web browser, and then we have a navigate method that loads the URL, and browsers here is a reference to the browser control. Another form of integration could be like a static documentation web page or a documentation. This is our Confluence web page integrated in the browser. And what we see here quite nicely is that the title of this form and also these navigation buttons are reacting to what we do with the browser. So when I load a page here, we see the cancel button was enabled for a fraction of a second because, well, the browser was loading something. So we react in the application on these events to provide the user the controls that he wants to see. And we see that now the back button is enabled because I actually have a history in the browser. There's something I could go back to. And I'm also seeing that the title of the screen here updates. So that's the title of the web page that has been returned to us. So we can take over a lot of the controls of the web browser using that way. I mean, most of that would be possible using the Internet Explorer integration as well, but with CefSharp, we just do the same using a more modern web browser. So let's look at what it means if we are building an application. So if we embed into an OpenEdge Fat Client GUI application the CefSharp control, and that would be then hosting an Angular web application built using or utilizing HTTP requests to an OpenEdge app server, then we actually have part of the R code of the application deployed to the client along with the GUI application that we've just seen, the browser control on the right-hand side. That connects to the database. And on the bottom right, we see we have an application. So either PaaS-OE or could also be classic web suite serving the web application. And that also has its R code and the database connection. Alternatively, we could implement the GUI application in a way that it also uses an app server. And then it actually gets quite interesting with PaaS-OE, because PaaS-OE allows us to serve from the same from the same application server instance, both the ABL GUI client using the app server protocol and using standard HTTP requests, either following REST or SOAP or whatever. We could be serving the request made by an Angular application running within the CefSharp browser control. And this architecture looks a bit more cleaner. We only have one path towards the database, and also which R code with business logic is where it's also much cleaner, because actually all the business logic is now running on the app server. And that would actually be a picture that would lead us towards a step-by-step migration of functionality from the GUI application into the app server and a modern web front end. So let's look at another important thing, and that's authentication. So when we look at these hybrid architectures there, we're actually looking at two different front ends, two different applications. We have the desktop application and the embedded web application. So the user starts the desktop application. So typically the user would be authenticating at the desktop application to begin with. And then at some point, he launches pieces of the application that are implemented as a web application. But that are two different applications. So if we don't do anything about it, that means the user would have to log in to these two different applications as the same user typically. But from an end user's point of view, he would be saying, hey, this is one ERP system or one whatever application. It's not my problem that you're implementing now some of the screens as a web application and others not. So please provide me with only one login to the whole application. Well, that's possible. Requires some things we need to do. It doesn't come for free. We want to do it also securely. What we can use here, and there are other solutions for this too, is we can use Securable. Securable is a product or framework for authentication and authorization. It's built from Notable. So it's the company, for instance, of Julie Noonan-Smith, who's also a member of the UK and Ireland PAC. That provides various APIs and allows integration with PassOE to solve these authentication problems. It provides ABL APIs to issue authentication requests to Securable. It also has a lot of functionality for authorization, and Securable has APIs that allow us from the ABL side to modify the master data used for the authorization or authentication. It's a system typically installed on the server, integrated then with the app server, PassOE, for instance, and could be deployed via Docker. I think that's Securable's preferred way of deploying it. And then what we could be doing is we can authenticate the user via various sources. So there could be usernames and passwords stored in Securable. But one thing that is really interesting is also Securable also allows us to use social authentication providers. So web pages like Facebook, Twitter, LinkedIn, Office 365 could be used for authentication. It provides integration with Active Directories, and it also provides callbacks into the Pro's application server or the OpenEdge authentication gateway, which actually allows us to use ABL logic to authenticate a user. And that's actually the integration with existing logins of an ABL GUI application, where you might have username and passwords stored in tables of your application. And that allows us to bring up a login prompt like this with username, password prompt, or we asked to sign in with Office 365. And especially in the last 12 months, where I think everybody has started using Teams or whatever, something like that for communication, the Office 365 login has become quite attractive. And then the user has to sign in using his Office 365 login, and we don't have the password in the application. So and how does that solve our problem of not having two different logins? Well, the desktop application could call into Securable for authenticating the user. And Securable could then be authenticating the user using one of its different methods that might be Office 365. Securable confirms the credentials, the username, password, and Securable could then provide us with an authentication token that we could query. And this authentication token is something that we can inject into the request of the web application so that there's no second login needed in the web application. Or the application could use Securable for authentication. That's the same thing. But Securable then calls using its PassOE integration or the OpenEdge authentication gateway into ABL logic that we write ourselves to ask for the validity of username and password. And then Securable still provides us the authentication token, and again, that's something we can inject into the web application so that the user doesn't need to log in there anymore. So there are these methods and tools like Securable help there. An alternative to Securable could be Keycloak, which is a completely open source product that we have experimented with too. But generally, one of these authentication products helps to solve these things. So now let's look at more user-friendly features that we can do here. One is navigating within a single page application. So What is a single page application? Modern web applications use the concept of single page web applications to navigate within an application from one screen to another without loading the full page. So 5 years ago, 10 years ago, all web applications have, whenever the user clicked on something, always reloaded the full page. And that's slower. And that also means for the user that maybe the scroll viewpoint of whatever he's working on changes. It's not so nice for the user. And that's why then with also more advanced JavaScript techniques, the single page web application have become the state of the art. And they typically have a concept of a router. A router is something that navigates 2 screens in the application. And the router functionality would either be triggered through JavaScript code in the application, but it can also trigger from the outside, and the triggering from the outside for browsers typically through the URL. And if we look at the URLs in the bottom, localhost port 3000, that's just my a web server hosting an Angular application here. And there, as part of the URL, we see that I want to navigate to the view called user maintenance. Okay, and how does that work? This is typically, well, in the sample that I'm showing you here in the Angular routing that we are using, it's using the hash-based routing. The hash character in web addresses is typically used to navigate to anchors in longer web pages. So if you look at this Wikipedia article there on OpenEdge, it's not the longest article, but well, it's not in this community one that fits well. So up to /wiki/OpenEdge, it's in the address of the page, and then hash history, it is really a jump marker within that page. And if we are already on the page and we jump using the URL from one of these anchors to the other, this does not trigger a full page reload. And for those of you for whom this sounds a little bit clunky, so why do we have to use a URL and something there which was made for long web pages to navigate to an application? Web browsers available since, well, the first half of the 90s have never been designed, and a lot of the basic concepts that web browsers and web applications rely on, the HTTP protocol, HTML, JavaScript, have never really been designed for building complex applications in the web. Yet everybody's using that for this purpose. And things that appear like a workaround are actually becoming the standard solution for things. And the hash-based routing for me is one of these things where this becomes very apparent. So router components in SPA frameworks like Angular, they can use this hash-based routing to address screens without requiring a full page reload. And this anchor that is part of the URL, that does not need to exist in the page. It's just something that triggers something from the outside. So that means using these 2 different URLs, we can navigate then to different screens, either the user maintenance or the security token maintenance, that are screens of our framework master database maintenance. They can be addressed through these URLs. And that doesn't mean a full page reload. And that means if the user has been on one record in the one screen, navigates to another one and comes back, he will be exactly on that screen where he has been before. So that's how it looks, but I can also show that to you in action. And to do that, I'm going to load or start a Docker container that basically just hosts a web server running our Angular application. And the PassOE that I'm using has already been started. And then as part of the menu in the GUI application, and from the same menu, I could be starting GUI screens, but I can also start browser-based screens. And in this configuration of this demo here, I'm not using Securable for authentication, so I have to re-log in on the web page. That's not the point here. So now I see the web application, and It actually hasn't launched the screen yet because it was busy with the authentication. But I stay in this tab here in the application representing a web browser, and I can now switch between these two screens, and I can select a record here, and I navigate back here, and I'm there. I can be in the middle of an update. So group browsers disabled, and that navigate here and back. And that's using a single instance of the CefSharp browser. We also see that the browser title bar is updated based on what I navigate to. And I'm just navigating to the server's address and using the hash based routing to jump to an URL. So that makes it even very, very easy to navigate using the GUI menu that the user could, for instance, also be using to launch true GUI screens. And if we would be working on harmonizing colors and stuff like that, then this could really lead to a very, very homogeneous appearance of the application, and definitely all of the functionality is triggered from the same menu. Good, so let's quickly jump to the next part. And that's what can we do besides navigating to screens in the single page web application to interact with that. So CefSharp allows us to communicate between the desktop application and the single page web application bidirectionally. That means from the desktop application, I can execute a JavaScript function running within the context of the web application. And the web application can raise an event that the CefSharp control exposes to the GUI application. And using that, I can have bidirectional communication. And that's just happening through the web browser controls, through specific functionality implemented into the CefSharp framework. And that means I don't need to use any form of external messaging, like WebSockets or JMS. So it's easy to use and no additional deployment tasks with that. And the use case that we have here is I want to use buttons in the ribbon of the desktop application to control the update state of the browser-based application. Why? Because maybe those screens which are still implemented in GUI are using those buttons, and that's where the user expects to find the delete or the save or the cancel button. And likewise, when the application is in a certain state, like whether it's in update state or not, maybe in the middle of an update, we don't want to allow the user to press a delete button. When we're in the update state, we typically only allow the save and the cancel button. It's part of our standard screen workflow. And that's something that's possible with this bidirectional integration with CefSharp. And so how does it work? So the CefSharp browser control, the .NET component, provides a method called evaluate script async. And within the parentheses there, in the single quotes, we actually see JavaScript code, which is then executed within the web page. And what we do there is we basically tell the web application, well, look for a toolbar called, well, it's a customer toolbar, for instance, and then execute the same event handler as when the user within the web page would be clicking the Save Changes button. This CefSharp call function there, that's a JavaScript function which we have implemented for our own purpose. So we have complete control over what it does. So we see here reference to the documentation of CefSharp, and that's how the function looks there. So it's called evaluate script async, gets a couple of arguments, well, timeouts, the line number that would be reported if that script has runtime errors. It's quite useful to get a stack trace that's meaningful to us, and the actual script source code. So, and now the challenge is a little bit the .NET samples that you'd find on the internet would then be using asynchronous method calls in the .NET framework, and that's something we can't do. So in the ABL world, we need to then create a reference to a task object. So that's then the bridge into the background processing there. And we would be invoking then through the browser or through a specific frame in the browser. Web pages are by definition always frame sets. We know frame sets from web pages where maybe a menu stays always on the left and then the content on the right. Every web page has at least one frame set. And then we call it the evaluate script async function that way. And with the task get a waiter, get result, we're actually waiting for the completion of that function. And then we could actually also get access to the result. And the result could be a string that would be returned to us with maybe some JSON data. And the opposite direction is, well, we want to be able to handle an event in CefSharp. Therefore, the CefSharp control provides this JavaScript message received event that we can subscribe to from our ABL code. And in the JavaScript code, so that is now JavaScript code as part of the web application, we have this this.cefsharp namespace. So CefSharp has been injected into the namespace of the browser window. And that allows us to send a message. And since JSON is the native data exchange format of JavaScript, it's quite nice to send JavaScript messages that way. And in the ABL, we have with the JSON object model parser, nice handling for JavaScript as well. So we usually exchange data through JSON strings. So let's see what that means. So I start the next example. And I started from the developer studio. It's not yet integrated in our application here. Still have been experimenting with that. Let's get the rest out of the world. So I'm starting this Angular example. So I have a very specific instance of this browser form. Taking a bit of time. So what I'm seeing is I'm seeing a browser for customer data. I could use these fields to start editing the record. So all this, what we see here is CefSharp. And we try to keep the appearance here flat like the ribbon so that it really looks like it's very homogeneous. But these buttons here are GUI buttons. And you will probably recognize these images. Progress is shipping them since version 9 as part of the ADM2. And when I start editing the record here, then within the Angular application, the grid becomes disabled. That's standard behavior that we have in our Angular component there. But also the toolbar here has changed its state. So the delete button is no longer enabled, but the save and cancel is enabled. So the Angular web application, when I started typing here, did send an event that we have received on the ABL side. And I can now use the cancel button to reset the record to its previous state. And that's then invoking the JavaScript function in the Angular application. And that's why it's very, very easy to interact from ABL through the .NET-based CefSharp framework with the JavaScript code or TypeScript code that the Angular web application is implemented in. And well, using that for toolbars is certainly one option. Another option would be we could use this also to fill out forms. So we could actually say, okay, well, we do an action here, and could even be a third party's website. And using a similar way, we inject data into a form of a third party's website also. So it's pretty much like our own form of a password manager, which also uses integration between the browser and the desktop component to fill out login forms in that case. So quite a few possibilities there. And with that, I'm coming to the end of this presentation. If you have any questions, please unmute yourself or put them in the chat and we can have a discussion on them. If you have questions later, don't hesitate to email James or myself. So I'm seeing no questions coming in.
You've explained yourself very well, Mike, I think.
Well, thank you, James. Well, then thanks for your interest, guys. Yeah, well, then hope you enjoyed the show and looking forward talking to you soon.
That's fantastic. Thank you very much, Mike. And thanks everyone for coming. I hope it's been useful.